Hi, so we're going to go over really quickly how to build and measure series and parallel circuits. So first thing, I apologize for my dog. He is going to make noises. Just deal with it. So we're in the PhET simulation. Now this should look really familiar. It was the one you guys used for the Ohm's Law lab in the last week. So what we're going to do first is we're going to add a battery right here. Oh, I got two. I'm just going to throw that one away. Boop. Now, I don't know if you guys tried this last time, but you can tap on the battery and you can change the voltage. Okay, so the reason that you would want to use basically resistors in series or parallel is something that I talked about in a previous video, which is you want to control the current. So the thing is, in the simulation, what's really neat is that you can take a resistor and you can change the resistance. And you notice the colors are changing because it's actually a resistor code. That we're not going to talk too much about right now, might come up a little bit later, but basically that would be something you couldn't actually do in the real world. In the real world, you are limited to what materials we can use in order to make resistors. So I would say the most common are in like the tens or the 1000, something like that, or like a 1K ohm resistor. So if you are trying to control the current in a circuit, you have to actually add resistors in order to get the right equivalent resistance. So here's how I'm going to do it for this one. Is I'm going to need some wires. So you connect the little dots, and then you're going to add resistors so that they follow each other. So the difference between series and parallel, series is like a TV series. So basically now we're going to have all the resistors are going to go in a path. So for most TV series, you would have resistor, or basically the episodes would go one after the other, like that. So for a TV series with a storyline, that's what it would look like. They go one after the other. So the biggest thing is the current only has one path to follow, which means there's one current throughout the whole circuit. Now, if you want to measure voltages, you put one little proby on one side, another little proby on the other side, and it'll tell the voltage across the resistors. Now, you might notice, Ms. Shreve, it's negative. That means my probes are switched. So instead of going from high to low, it's going from low to high, which was negative. Just take the absolute value of that number. Now, if I want to, say, measure the current, well, I'm going to basically cut my circuit, and I'm going to put my little ammeter in there, and so now I have the current. So in theory, if I were to cut the circuit in other places and put the ammeter in other places, or actually we've got multiple ammeters, let's just do that. The current should be, you can put basically different ammeters in different places in the circuit. Oops, sorry, hit my microphone. So that's kind of what we're doing with this one. All right, so the big thing is for ammeters, it has to have the current go through it. So you see how like the little ideas of electrons are going through that thing? That shows you that the ammeter is actually taking the reading of the current that's going through. Voltage is basically the voltage across. So you just touch both sides of the thing and you get the voltage. Okay? Now what this would look like in terms of a resistor or a circuit type drawing is like that. Okay? That's a good idea to look at as well. Okay, that's series. So I'm just going to go ahead and in case you want to sketch this down, I'm going to just write what this is. This is, oh, sorry, it won't let me do it. Oh, won't let me do it. That's fine. Okay, it won't let me annotate, but this is series. All right, let's go ahead and do parallel. So same kind of idea. So I'm going to switch back to the regular setting. So we do the battery. Now parallel means that things happen at the same time and it will make parallel lines. So the best way to do it, so you don't get confused, is to literally make the resistors parallel to each other. Okay? So then we're going to add some wires and we'll connect it. Now, that's not doing anything because it's not connected to a battery. Now, the people always ask me like, well, Ms. Shreve, I connected them in parallel and nothing's happening. You're not connected to the battery. You got to connect to the battery. Okay, and here we go. And there we go. Okay, so there is our series or our circuit in parallel. The reason that we call this parallel is one, parallel line. So if you see it in a circuit diagram, that's what it looks like. The other reason is because things happen at the same time. So basically the current, basically what this voltage source actually sees is not three individual resistors. Now, when I say C's, imagine I'm doing like air quotes like C's. What is happening is basically the current has multiple branches it can travel, but remember the electric field is what's actually traveling between things. So what has happened with the electric field is basically it sees what's called equivalent resistance of these things. And that's actually what you're looking for in your experiment is what is equivalent resistance for these resistors. All right. So in terms of taking measurements, it's very similar to the series circuit. So you put your ammeters in different spots. So for this one, you do want to take current for each branch, okay? Because you want to see what's happening in each branch of the circuit. So you'll do this. There we go. And so you'll have, actually, you really do want to have one more because I do want you to take total current as well. So basically, you'll put an ammeter like that as well. Okay, so what you'll have is a current meter for each resistor in each branch, and you'll have a current meter for basically the current that's going back from the branches together into the battery. Or you can do either side. It will be the same on this side or this side. That's actually one of the important rules of circuits. Now for voltage, you're going to do the same kind of reading, like going across like this. So you'll see kind of what the voltage is across each resistor. Okay. You'll notice in the lab, it actually asks you to look for both things for this. So that's basically how you do things in series and things in parallel. So this one's parallel. Series would be just one straight line. Pure parallel is multiple lines like that. All right. Good luck. Hope you have fun playing with circuits.